Hello everyone. In today's video we're going to be talking about Physics 252 Week 4 problem number 3. In this problem we are tasked with finding the gauge pressure at the bottom of a giant ice cylinder. There's kind of a borehole of ice right here, and we need to find the pressure at the bottom. We also want to figure out why physicists are doing this, which, to be honest, did take a little bit of extra research, but you learn something new every day. So let's get into the problem. To start off, I think it's important to note the depth as well as the density and our gravity, because we're going to be using a problem that we just, an equation that we used a lot in lecture this week, kind of relating this rho GH just to various equations or various problems. So we're going to go ahead, let's look at my drawing here. So I have, what I've done is I've put our ice hole at sea level. So this means that it is at 1 atmospheric pressure. We can just say that this is equivalent to quite a lot of Pascal. Not a ton, but relatively speaking. We can also say that it's of a certain depth here, and this it's going to be, this row right here is just kind of me trying to tell the density of water. So what we can do from here, we know that absolute pressure is equal to the gauge pressure plus the atmospheric pressure. Well, we have atmospheric pressure, and we can calculate for absolute pressure. So if we rearrange this equation here, we are left with this right here to solve for gauge pressure. So I've gone ahead and laid out our constants here that we're just going to plug straight into this equation, as I've done here, and as well as our ATM, in Pascal, and just kind of solving along here. This is our final gauge pressure that we end up with, this is a pretty cool problem though, because what physicists are doing when they're drilling these holes is they're trying to find neutrinos. So neutrinos are very different compared to a lot of other physical properties in that they travel really fast. So because this cylinder here is full of water, what they can do is when the neutrinos go into the water, they slow down quite a bit. So when they're going slower, they can try to detect them in the water. And I believe that there's multiple ways that physicists do this in Antarctica, one of which that I find a little bit cooler is that they have a giant hot air balloon, and then they use all of Antarctica as the water. So I thought that was pretty neat. This is mainly CERN ran experiments, so I'm sure that has some reason to do with the connection to our class, seeing as our professor has had some experience working for them. So I hope you guys found this video helpful, and thank you very much for watching. Have a great week.